Hello and welcome to today's expert panel. And we have a fantastic panel today talking on the secure device management for the Internet of Things. Let me introduce you to our panel. My name is Jeremy Cowan. I'm editorial director and co-founder of IoT Now, and it's my pleasure to be your moderator today. Thank you to everyone for joining us. We have people attending right around the world, and that's for one reason. We've got a good discussion for you, brought to you with Wind River and Intel Corporation. So the best thing to do is to introduce you to our speakers. The first is Randy Thompson. Randy is Director of Product Marketing at Wind River. It's really good to have you here, Randy.
Thanks, pleasure to be here.
And our second speaker is Cesar Martinez-Peso, who is Senior Solution Architect and IoT Solution Manager at Intel Corporation. Welcome to the webinar, Cesar.
Thank you very much, Jeremy.
Well, today we're looking at, as I say, secure device management for the Internet of Things. Let's just call that IoT for short. The IoT is enabling many of you, as you know already, to transform your business and significantly to improve your products and services performance. But we all know that wherever there are new business opportunities, they do bring new problems. Your success, indeed your customer success, is going to depend on securing these connected devices. So Wind River and Intel are here to tell you about the key trends that are driving IoT security, some of the real concerns about your devices and their security, and the risks that IoT companies face if they fail to plan adequately for that security. Just to let you know, this webinar is being recorded, and tomorrow you can stream it from our website, which is www.iot-now.com, iot-now.com. We also want to know what you think. So in a moment, we have a live audience poll. And later, we've allowed time for your questions. You can start sending them to me right now. After the presentations, I'll put your questions to our panel. Just click on the questions button and type your query into the window. And of course, any that we don't cover will be passed to our speakers so that they can answer your question offline. Finally, if you're having any technical issues with the audio or with the slides, you can use the same question window to get advice from our superb tech support team. The poll that we want to run today is as follows. You have a choice. It's a one answer to give. The poll question is, who is responsible for IoT security at your company? Is it the IT department, software developers, the security department, your vendors, or is it someone you don't know? So feel free to answer this question. It's completely anonymous. Nobody can see who's replied in what way. Who is responsible for IoT security at your company? Is it the IT department, software developers, security department, vendors, or you're not sure? Let's have a look and see what people have said. Well, the greatest number and the most logical answer is, I'm pleased to say, a security department at 37.5%. Close behind it, 35.5% software developers. And just behind that, the IT department. Only 14% said vendors, and 6% weren't sure who is in charge of security at your company. Randy first, is that in line with your expectations, Randy?
You know, I'm not sure what I was expecting, but I did not expect it to be so even. But it actually turns out to be the perfect answer, because one of the points I was going to make coming out of this slide was in the end, it's everyone's responsibility.
Yeah.
So
yeah,
good to see.
Cesar, what was your thought when you saw that reply, that response rate?
It's completely related with the work that we have been doing regarding security. And I think that, when we show all the implementations that we did and how we go with security and how we implement the security, we will have, an answer for the security department that is, related here.
Well, it seems the logical solution. Let's crack on with the webinar proper. In a moment, I'll hand over to Randy Thompson, as I say, of Wind River, and afterwards he will pass directly to Cesar Martinez at Intel. Randy, the floor is yours.
Okay. And we do have to recognize in that question that the audience, some people are with equipment manufacturers, some people are with end users, and so the department may be different depending on whether you're building products or whether you're consuming products. But still, it's interesting that it was so evenly separated. So I'm going to start the conversation today with a thought exercise. So let's say that you're out on the street of a city somewhere, and this guy walks up to you and asks the question, "May I have your car keys?" What is your first reaction? And I've done this presentation a number of times. I know everybody's sitting there going, well, no, why would I give him my car keys? And then if you thought about it a little bit, your next question would start to be, well, why do you ask? It's just such a funny question out of the blue. But if you think about it, when we go to our customers and we say we'd like to connect a device in their network environment, and we don't give them any context other than, hey, we need to make this connection, we should see the same reaction. Like, well, no, why would I let you do that? And it's the why that's so important. So what's the difference between this individual walking up to you on the streets and asking for your car keys, or the example that we see on the right where the woman is pulled up to a place that's got a sign that says valet parking? Now, her relationship with that person she's giving her keys to is probably the same. It's an unknown person, but it's the context that makes her comfortable to hand over her car keys. It's context not only of the sign, but the location, expectations perhaps from past experience and so on. But it's part of why security is such a difficult topic to discuss, because it's not only the mechanical things that we do with the technology, and we're going to talk about those a lot, but it's also all the things that go around that, all the signals that the product or the packaging of the product or the business case around it send to help people be comfortable. So anyway, just an interesting way to think about it. So now let's talk about IoT and the bigger topic of digital transformation. Digital transformation is really bigger than IoT. IoT is like one piece of it. Like, let's get connected to things and bring that information back. But to really transform a business, you have to have that information flow throughout the company or throughout the enterprise. And I often tell people or suggest that the value of IoT is not in the collecting of data or the moving of information back and forth to the edge. It's actually when people make decisions. That's when digital transformation starts to happen. And once you have this concept in place, you have this connection out to things in the field, you can start to do things differently. You can make decisions faster in a different way and more informed and so on. And these can all impact your business by creating new services or new ways of doing business or just ways of doing things better. It's also important, this is why, to come back to security, it's great that we can have all these wonderful benefits and go out to customers and say, hey, we can connect to your machine and we can monitor how it's doing and we can proactively send a service person or we can call you if there's going to be a problem. But in the case of factory automation, for example, where we have things that spin or things that are heating up or things that can blow up, there's a legitimate concern for, well, if I let you in, does the benefits of allowing this connection outweigh whatever the risks might be? Same thing, this is true across all these big industries. In case of transportation, though, it doesn't always have to be the train or the thing that's moving. We have a customer that makes ticketing kiosks, and even just being able to make sure that those kiosks are working all the time so that people aren't having to go over to the window to manually buy tickets and so on is still a really important piece of the entire puzzle. And not having to wait for the machine to break and have somebody call and then dispatch somebody. If you could actually work on it remotely, that can make a huge difference. So I think everybody gets the idea of why IoT can help our business. Now let's talk about kind of the realities around security. One of the things that's, if you look back at computing over time, we started off with mainframe computers. And everything was a green screen connected to the mainframe. So as long as the mainframe protected itself, there was only so much users could do from their computer terminal. Then the PC came along, and the world changed. Everybody suddenly had the power and the ability in their, at their fingertips, at their desktop machine, to pull information down, and they didn't want to be connected because network connectivity was, except inside of a big business, wasn't reliable enough. So I needed to do everything on my own. So it became very much more towards individual points of ownership with maybe a connection back to a server. Then when the mobile phone wave hit, it flipped over again. Now the phones, they can do amazing things, but for the most part, they can only store so much. They need to talk back to some place, so they need to talk back to the cloud. So we ended back into a more to a more centralized model where the information is stored at the cloud and the phones are just viewports. And where IoT is taking us is back into a more distributed model. Now we're pushing intelligence out to the edge. The cloud is there more for coordination or for storage. And as we see some things that are coming with fog computing and so on, we may end up with a really closely a hybrid model where we've got centralized and decentralized all mixed together. So but just understanding how things have changed and how the pendulum is swinging helps understand some of the security challenges. Intel did some research and went out and talked to technical and business audiences about what the biggest challenges were for IoT. And it's interesting, the technical guys got it. They know that security is an issue because this is something that's very close to the surface, and it's something that they have to deal with when they're thinking about designing a product. Obviously, the ability to connect things together and integrate data and do analytics and so on are all important, but security was number one. When they talked to the business audience, the issues and the concerns were more around, are we going to select a solution that will be with us for the long term? It was more strategic. Is the system going to scale according to our future plans and needs? Is it cost effective over the long haul? Security was actually number three. And thought that was it's kind of interesting. Just shows how the two groups think differently. But in the end, I think security, if the business audience truly understood the risks, security would be number one for them as well. And these security threats are real. There's been some really spectacular examples. One that's interesting to me in the context of this discussion is the Mirai botnet that was created. So this is a computer virus that, for lack of a better description, that searches the internet for these home consumer devices of a certain type. When it finds one, it goes through a dictionary of 60 default admin login passwords. And when one of them works, it then gets access to the device and installs itself and then proceeds to go look for more devices. So it's incredibly simple in some ways, but it's smart enough that if it finds another bot there that's like it will delete it, that kind of thing. The result of this was that the bad guys were able to put together a network of something like 500,000 devices around the world that were all talking back to some central control point, and then they could use them in a coordinated way so that they could do denial of service attacks and who knows what else. What's interesting about this example is who's at I don't want to say at fault, but who is responsible for all of this, and then who owns the problem? Because we've got consumer companies that race to market with devices and sold them to consumers. Consumers put them in, and they enjoyed the benefits of internet connectivity for being able to see their, cameras or whatever. But the impact of the attacks was actually on other businesses. So what we begin to see here is that the lack of security by the manufacturer of these consumer devices ends up resulting in a risk to someone else. And it was a very big risk. Took down a DNS provider for a while and caused all kinds of disruptions in the internet. But it just shows how, I guess the kind of the unintended consequences if you don't think these things all the way through. But in the end, we've got consumer devices that are not updatable in the field, and so they're defenseless. They'll continue to be a problem as long as they're sold and as long as they're connected to the internet. Another example is the St. Regis Shenzhen Hotel it's in Shanghai. But in this case, it's a high-end hotel. They built a really cool capability where you can control the TV and the lights and the window shades and everything from an iPad that they make available in the room. And a hacker was staying there, and he realized that, he was intrigued by this, and he realized that, okay, if he sniffed the network, he could figure out kind of what protocol they were using and what the devices were, and then he figured out how to talk to the devices. So he actually got to the point where he could get on the network, and he could control the lights and TVs and so on of any of the rooms in the hotel. So here's a case of where somebody thought, okay, we're just going to build a system. We're going to use off-the-shelf components. Pretty straightforward. But I think the assumption was because it was all inside the hotel, there was no risk, or there wasn't the concern, there wasn't a feeling like, oh, we need to think about this as a exploitable system. Where in reality, even somebody who's staying in the hotel can gain access. And once you've figured that out, it's not a big jump to be able to figure out how to do it from far away. But just because a system is going to be self-contained within an environment or a factory or a machine does not mean that you can ignore thinking about security basics. So when we look at the Internet of Things, the model that people often have in their head is pretty simple. It's really, there's a cloud, and then there's some smart things and actuators. So it's almost a point-to-point thing. I've got a cloud, I've got smart devices, they talk back and forth. But one of the things that's changing or that's happening because of wanting to connect devices is they're getting on a network that they weren't before. I worked with a lot of legacy devices that were designed 5, 10, 15 years ago, and there was no expectation these devices would ever be on the network. So they didn't try to protect anything. There's no authentication. The expectation was, well, a service engineer will show up with his laptop, he'll plug into the port, and he'll run his diagnostic routines. And now when you start saying, okay, we're going to make this a connected device and start doing IoT things, now we are connecting it. So there's two challenges. There's the brownfield challenge of how do I connect things that are already out there and weren't prepared for that versus how do I design new things so that I can build that right from the start. Now it's getting more complicated because what we're starting to see as IoT is becoming more mature is that we can't wait for communication from the edge all the way back to the cloud every time something needs to happen. We need to coordinate things, and so the concept of fog architectures gets introduced. So now we have another layer. So each of those fogs looks like a big IoT picture from before. They're just, it's kind of like IoT systems talking to IoT systems. And all that really does is present more surfaces and more points of entry for an attack. So when you look at these systems, you really have to look at them from the bottom to the top. And at each level, you have to think about, okay, what is this device? What information does it have? Who does it talk to? How does it talk? And look at each one of these and make sure that, okay, take all of that reality of how things talk and who and what, and mash that against the risks of what kind of information they have and the risks of what happens if somebody was to get in the middle of that. So the DNA of Wind River is very much at the edge, and so we tend to start with devices when we're thinking about this kind of thing. But in a software-defined world, security all begins with the devices. The devices are the point where the decisions are made locally. They're taking the sensor input. They're driving the actuators. So if someone can gain access to the device, that's the best place to cause the most trouble. You can make the sensors readings be inaccurate or incorrect. You can drive things to turn on or turn off when they're not supposed to, that kind of thing. And what makes it difficult is there is no universal platform. This isn't like everybody's got a PC or a Mac and they all are essentially the same. They are all over the place because a different development department built each one of these products. So you have to, this just complicates the job, but it doesn't make it impossible. When you do set up to design a device or to go back and retrofit one, you have to kind of think about this, the security of this device. How are we going to protect it? Well, we obviously have to start back in the design mode. This is a cultural problem, not as much as anything. People have to think about security from the start. It's much easier to build it in at the beginning than it is to do later. So how do we, through code reviews and how we handle source code and so on, how can we make sure that no one can get in and do something? And I think that you also have to think about this a little bit with open source. You have to pay attention to what you're bringing in. Once I have a device, when this device boots up, how do I know that it booted up with the original OS and BIOS that I shipped it with? And so there's some, there are technologies to be able to do that. When it's running, how do I know that the system is protecting itself? How do I check who, what ports are open, who can connect to them, is authentication required, that kind of thing. And then in the end, I'm going to ship these devices out into the world. They're intelligent. They're going to connect to a network. How am I going to update them in the future? Is it going to require somebody to go there and actually manually do something, or can I do it over the air? Now, once I have my devices secured, I also have to look, because this is a whole system of connected things, how do I manage the connectivity and who's connecting to what? So what needs to be communicated? What data, control or commands, data only, one-way or two-way, one-to-one, one-to-many? All of these things impact the security risk, the security threats, and need to be considered. In that hotel example, they were using a protocol, a common industrial protocol. There was no authentication. Once you were on the network and knew kind of what was going on, you could send a command to anything, and it would happily accept it. And I made the point earlier about devices being updated. In the end, you have to assume if you're going to put a device on a network and it's going to have enough intelligence to communicate, it will eventually be cracked one way or another. And so your only real defense in the long run is, can you push updates out to that device? Not only to protect it and handle any new security threats, but also to keep adding value to the device and keep its lifetime longer. So an updating strategy and a device management strategy should be a part of any IoT design project. And one of the things that we do at Wind River is we have a product that's around device management. And so we started looking at the life cycle of an IoT device to get our hands around what are the important elements of that. Well, there's obviously deploying devices. So when you push a device out in the field, how do you know when it talks back to the cloud that, number one, it's allowed to talk back to you and that it's who it says it is? Once I have a device connected, I need to know what its health is. Is it running okay? Has it been exploited? Ideally, if I'm going to monitor it, I don't really get any business benefit unless I can actually work on it remotely. Otherwise, it just told me there's a problem and saved the customer having to call me, but the real benefits come from being able to fix things remotely. And then I've talked a lot about updating devices, but just knowing what the inventory is in devices, especially for devices that have field replaceable components where service engineers or customers are in and out of the device all the time changing things. Very helpful to have a centralized inventory so that now you can know I have this many devices that have this version of software running that have these options installed, and do I make a patch for that? And if I do, can I target those devices? And then, of course, anytime you connect things, there's also a disconnect process. So decommissioning devices is important. And it's Wind River Helix Device Cloud product. This is the product that I'm working on. Is off-the-shelf set of capabilities for being able to do monitoring of devices, do secure connectivity, have a centralized management, browser-based management console so that you can see the status of all the devices, you can interact with them for diagnostics and repair, and also for pushing updates. And then we have integration capabilities to plug into other systems. So I guess just to conclude here, I think IoT at this point is inevitable and pervasive. It's going to be everywhere and in everything. And given that, we need to be thinking about how we protect this new environment, we've got to add some new layers to our thinking of product design. IoT is a very complex computing model or architecture in that we've got things talking to things, which talk to other things, which talk to other things. So there's a lot of layers that can be interrupted. And in the end, if you can't update things, it's only a matter of time before that device or that layer is at risk. So with that, what I'd like to do is turn it over to Cesar with Intel. He's been doing some work that will show or highlight some of these things that we've been talking about. So with that, Cesar, over to you.
Thank you very much, Randy. So, as you know, Randy mentioned it, I work in the Customer Deployment Engineering team, part of IoTG, the Internet of Things group. And basically, we specialize in IoT instrumentation or deployment in customer. And what I would like to show you in this presentation is how we implement security and manageability in our solutions. For that reason, I choose one of the most common use cases or an industry that we really know, everyone, because we live in it. That is the smart home, our homes. And we all of us know the drilling and the situation of our home, the need of our home, and also we know how the home are evolving into the market, in a place where they are converting more smart and smart. Today in the United States and also in Europe, you will find in several markets that you find different devices like light bulbs, actuator sensors that are working in order to make our home more smart. And before going to the technical details, I would like to tell you a little bit about why we are doing these things and the challenge that we found to the market. So in the very beginning, we find in the market different sensors, different actuators, all of them, some of them connected, but many of them disconnected. So we found an opportunity here in order to concentrate and put every single point to work together. And our vision started to be, just to, have all the perceptive communication. That means using a sensor or, or a camera to monitor, for example, if someone is in our home, understanding the temperature of the home, or if the door is open or closed. We start with that perceptive analysis just to inform to the customer, to the end user, the different situation of the home. Going as a next step here, we are looking for, as a responsive state where the home not only understand what happened inside the home, but also it gives you some, advice or is changing the behavior of some of the actuator. Like, for example, if a PR sensor, a presence sensor, detects the presence of a person, could start the air conditioner or the heater. And as a next step, we work in autonomous. The idea there is the decisions are being, taken by the home, and with this, the home can start, for example, or change the light based on the different behavior in the home. One simple example is when you turn on your home entertainment center, the lights can change or can modify the colors and the different dimming, okay? And, going through the vision and pushing for that vision, we found many challenges. As you know, there are a lot of device proliferation. It's a very fragmented market. There are many protocols, many chipsets of communication working into the market, and many of them are not aligned. So we work in our Intel Gateway in order to make the alignment between all these components. And one of the bigger barriers to adoption for consumers, what I found, and every time that we're presenting, is the security. Many people, they don't want to put, video cameras, PR detectors, or other devices, basically because they don't understand the security, and they are very concerned about someone hacking their homes. With this, as you can see, one of the top drivers of the smart home is basically security and control. So people want to have a security system, but this is the place where the people are asking, how secure is your security system? And it's a challenge that we have in the industry based on the different protocols, based on the different devices that you have. Adding to this, I would like to show you a very common use case and showcase you, basically what happens when someone is, turning on or working with an actuator in your home. Here in this slide that we will read from the right, you have the Amazon Alexa. The Amazon Alexa is a speaker and many microphones. Then when you speak to the Alexa, Alexa has a connection between your device, the hardware, and the cloud, the Amazon voice recognition. And with this, they will parse basically your voice that is sent to the cloud, that will send to the cloud, and after they recognize the command, will communicate with your device and, will push for the actuator. Like, for example, if you say, turn on the TV, okay, the voice will be sent to the cloud, and then Amazon, will send this information to an actuator specifically. When we implemented this thing with the customer, they found that, there is a lot of opportunity here for security. And basically, who will authenticate that this is the right cloud, okay, that this is the right AWS cloud or the right instance to push for the actuator to action. Or, for example, when someone else is trying to hack into the system, how we recognize that it's not in the middle that is talking with the actuator. So for that reason, we secure the implementation by using Healy Device Cloud. Healy Device Cloud helps us to authenticate, first of all, the connection between the two clouds, the Amazon Web Service Cloud and the Healy Device Cloud, to have one single point of connection there through certificates. And then in order to send the command to the home, we authenticate with our gateway, okay, that is a hardware gateway that will have a hardware root of trust where we can identify one-on-one the Healy Device Cloud and also the gateway that we need to connect. So you will have a secure connection. And of course, we have encryption in the middle to send the command to the gateway. And as on the last point here, we authenticate and connect with the actuator, and with the actuator and the specific actuator, we will encrypt the communication and send the command to the specific light, for example, if you want to turn on the light, or the specific TV, going to my example in the very beginning. So if you see, there are a lot of points here to consider, just only when you say, turn on the light, turn on the TV, regarding security. And this is what Randy was mentioning a couple of slides ago, where they found many situations in the industry. You find many situations in the industry where there are a lot of hacking in this kind of action, that is turning on, turning off the light sensors and temperatures devices. So for this particular customer, we implemented this secure protocol just to solidify the communication between the different devices. And I would like to show you how we did that, going and reading down a little bit more about the bill of material that we put all together. This is a platform that we have, and we work together with Wind River and Amazon and third parties in order to build it. So the platform is what you will see here in the square, okay? In the very first start, I mentioned to you that we use gateway, hardware gateway, where Intel specializes in different chipsets. The chipset for this market that we are implementing, but we have several others, specifically for the implementation that we did in 2016, we did using Quark and Atom gateways. Okay, you will see here the pictures. And these Quark and Atom gateways are done by our ODMs, and they sell to the market these gateways. These gateways has different capabilities of communication, like working with Bluetooth, Zigbee, Wi-Fi, Z-Wave, or 3G. And with this, you can connect with several devices. We talk about the device proliferation, and it's exactly what we are trying to solve here, this challenge that we have into the market. So you can communicate with many devices and with many different protocols by using this gateway. So going into the details, specifically about in the square box, we need to start from the very, very beginning. As Randy mentioned it before, you need to think about security from the starting point. And one of the starting point is basically what you have in the BSP, in the BIOS of the hardware, and what you have in the operating system. So we work, very hard in order to secure this point. In the operating system, we use Wind River with Wind River 9, and also we use IDP in 2016. So there are different flavors of Wind River. These are the two that we implemented, and also through all the Wind River operating system, all the layers that you have security connectivity between this level of the operating system and the drivers and containers that right now you're using Wind River 9. These drivers are authenticated, that is secured by the operating system. The driver that we work is, as I mentioned before, Bluetooth, Wi-Fi, Zigbee, Z-Wave, and 3G, 4G for Telit. And of course, with this connection, we have several other flavors, like, putting a buzzer or adding, a particular protocol for communication to the device. This also is, was implemented in a security standard for Wind River operating system. In addition to that, I would like to highlight, and I put here a security layer that is, from the very beginning, we have TPM, the trusted platform module. This is basically a hardware chipset that allows you to identify the gateway with just one ID, and also to have an enclave where you can encrypt and decrypt the communication in the hardware. The next step that we have here is the secure boot. Secure boot is easier to understand when you think that if you have a pen drive and you have a USB drive and you have an image and you want to boot in your machine, usually in the PCs or Macs, you can have a way to boot from the USB. For these special devices, you know that this will be challenged because someone else could enter into the gateway, could enter into the device, and then after that try to hack, the complete infrastructure. From the very beginning, we have a secure boot mechanism where we authenticate through certificate and keys the boot of the image that you want to boot into the gateway. So anyone that is trying to put a USB or a new trying to boot the gateway, with a different image, should have this encryption in order to make it work. If not, the software will not boot. And the other thing that we have, where Healy Device Cloud help a lot, is in the secure data ingestion using DXL, secure data encryptions of the files and the data that you have as a root. Secure update. We all know that the software will change. This is a common thing that we have in the industry. The software will change. So how to change the configuration of the gateway, how to change the software of the gateway in a secure way? This is the question that we have from many customers. We don't want to have a hacker trying to update your gateway with malicious or a virus put in there. So what we have with Healy Device Cloud, and also using the Wind River operating system, we have a secure mechanism in order to encrypt and and authenticate using a certificate the upgrade of the gateway. And when I talk about upgrade of the gateway, it's not only the upgrade on a specific library or a software, but also the upgrade of the complete image of the operating system. And last but not least, here we have the secure edge registration. That is the kickstart when you are turning on the gateway, how you encrypt all the things, and the gateway lockdown. The gateway lockdown is very important because once that you have a gateway that is working and you have in a functional way that you like, Wind River operating system provide you tools in order to close the gateway and just use the applications that you currently are executing until you upgrade again the gateway. So the idea is that you lock down all the applications, all the data, so you cannot modify easily without having a key. So and last but not least, here we have the things done with Healy Device Cloud, that is the images and the factory reset, the gateway update, and the application update that you can do. You can use using the cloud. From the cloud, you can upgrade, modify, and update the gateway in a secure way. This is how we implemented in this solution, together, as I mentioned to you, with Amazon, which Amazon provides several of the modules and equipments in order to do all the data analytics and data ingestion. With this, I think that I'm looking forward to wrap up. So this think that, is all for that. So I want to, go back to Jeremy for the round of questions and Q&A.
Thank you very much, Cesar. We are now at the point where we to ask your questions, and I see that a large number of questions have come in. Thank you. Keep them coming. Any that we don't get to on this Q&A, then let's discuss offline. I know that our speakers will be happy to take your questions later. The first one is from Finland and says, what are your recommendations for best practices in device authorization? Randy, what's your thought on that?
Well, it's an important thing. So, and there are different layers of this. So in the Helix Device Cloud product, as a standard, we put a certificate on every device, and then there's a mutual authentication on first registration where we exchange some unique information from the device, build that in the certificate we return, and so from then on, all the communications from that device is known from that device. Where we really need to know for sure that the device that's talking to us is truly who it says it is, we'll go to something, Cesar mentioned TPM. That's an Intel technology that actually goes in the silicon and can be used as another level of making absolutely sure the device is who it says it is. But I hesitate to make a recommendation other than to say there are choices.
Yeah, that's pretty fair. Cesar, is there anything that you would add that you think is best practice for device authorization?
Absolutely. The hardware roots of trust that Randy mentioned is a key thing. And, begin the security from the very start. That is, when you go to production, when you build your hardware, this is where you need to start the security authentication and identification, working with the OEM, system integrators, and, different partners in order to build the security end-to-end.
This is probably one for Randy. Is Amazon Alexa using HDC, or was the architecture presented just as an example?
Actually, that's Cesar's question.
Yes. We work with Amazon, the Amazon team, very closely in order to have a solution working with Helix Device Cloud. And I cannot speak from Amazon, okay, and from Amazon Alexa, which is the technology that they are using there. But we work with Amazon in order to have Helix Device Cloud and offer this combination to customers that are concerned about security.
Thank you, Cesar. Randy, what is done to protect against eavesdropping analysis where you infer details about an IoT ecosystem status by monitoring traffic patterns? Is that something you're in a position to answer?
Well, that's outside of the scope of what we're normally concerned with. It's an interesting question. I think if you had a set of devices or a use case that was pretty homogeneous where you could see, hey, if they're chattering more, then there must be something going on, you might be able to draw some conclusions. A lot of the kind of work we deal with companies where they're just monitoring device status, they're sending data on change or on event. So, and a lot of it is just system health kind of stuff. So it would be hard to draw any real conclusions other than that things were on. But it's an interesting thought.
Yeah. There's another question here from a well-known professional services company. Hardware-based root of trust is established. There's not a lot of information here, but he's asking, is this during production?
Yes, absolutely. This is done in production, as I mentioned to you. This is a chipset that you put while you are working with an ODM when you are making the PCB. Okay, and also is the OEM, the person that is doing the gateway, the one that will identify which are the keys that they want to use at the very beginning. and start with this to provide this thing to the customer. But the answer is yes, it's in production.
Yeah. Actually, Intel has a group that's working on a project right now where you identify these devices using some secure, something in the silicon, and they're building a system where you mark the device when it's manufactured, and then as it moves through your supply chain, you have a way of transferring that device from, let's say it goes from the manufacturer to a warehouse or a distributor, and then from the distributor to a reseller, and then a reseller to a systems integrator. They're building a system where you'll be able to transfer that device's ownership. And so when the device finally lights up in the field, it will check in and get information sent to it about, here's what your owner says you should have, or here's some software your owner says you should have on it. So I think that kind of shows the future, especially for high volume customers that are selling through a multi-level distribution chain, how things are going to get much more sophisticated, but very much based on knowing absolutely this device that left the factory is who it is and who owns it.
That's a good one for the future. Here's one for the here and now. Questioner wants to know, says the IT department won't permit external connections from our network. Does that mean we can't do IoT? That's pretty fundamental.
Well, it does. IoT is a big thing. You could do IoT all completely inside of your own environment. But I've seen this a number of times with semiconductor manufacturers and with pharmaceuticals and also Department of Defense and so on. Generally, there's a very good reason why an IT department is cautious. But what I've found is it almost always comes down to business value. If there is a legitimate reason to connect something because it will help the business achieve its real mission, the IT department can find a way to make it so, whether it means isolating the network, maybe doing it on cellular so it's never truly on the network. There's lots of choices, but just like my example at the beginning where somebody asks you on the street, can I have your car keys? That's the default mode for IT. So it really becomes a matter of getting the business owner of the machine to say, hey, if I'm going to achieve my production goals or output goals or efficiency goals or whatever, I need my supplier or my advisor to have connectivity, and so therefore let's figure it out.
I think I know the answer to this, but I'm going to ask it on behalf of somebody anyway. Is there a recognized standard for security?
I wish. It would all be so much easier if we could just go to one place and say, please approve my device. The answer is they're not, and there's probably not going to be just because the nature of devices are all so different. But I do see the world moving towards accepted methodologies for validating security or for verifying or testing a system. And so it's going to be, for a long time, it's still going to be a deal where you have to go look at the artifacts or the proof points that manufacturers are able to provide about how much certification they've done.
Yeah. So, Cesar, is there anything you want to add to that?
Absolutely. What Randy mentioned, what we implemented, working with IoTBT, SSL, DMCrypt, using MQTT, with SSL is all regarding a lot of protocol proliferation and different protocols that are working in a different way. They are not a common standard, and of course we are looking to support all the standards possible and all the different protocols possible in order to have a seamless security into the gateway. I think that this is one of the challenges that we need to work with.
Yeah. While I've got you, Cesar, here's one from a cybersecurity company that asks, is Intel Gateway Solutions for IoT available on the market? Could this be implemented in or aside consumer class gateway routers? Could this be implemented in consumer class gateway routers?
Absolutely. Yes, absolutely. We have different gateways for different needs. okay, with different certifications, depending upon the market, depending upon the use cases, okay. And yes, it can be used for consumer market. In fact, the one that I presented before was intended to be, implemented in the consumer market, and we did it.
This could be for either of you, but I'm going to ask Randy first. Somebody wants to know, how do I build a business case around security for IoT?
This is one that fascinates. This is a topic I've thought a lot about. It fascinates me because security is a little bit like selling or buying insurance. You know it's a good idea, but at the same time, you spend the money, you're never sure what you got until you need it. And so, do I need a big policy or a little one? Am I trying to protect myself from just disaster or from everything? But anyway, to build the business case, it really comes down to what is the risk to your customer or to your own business, and what you almost have to just go through a whole process of what are all the bad things that can happen if somebody was to crack the system. Could they damage machines? Could they harm people? Could they steal secrets? And for each one of these, what steps have we taken to mitigate against them? Anyway, as far as the business case goes, it's really simple. How much money or how much risk are we willing to take, and what's the potential magnitude of that risk if the worst case happens? And it's a very hard picture to get management to comprehend, because you almost have to have an event to get people to finally wake up and go, oh, why didn't we do anything? So, yeah. But the more you can quantify it, the more you can make really clear visual examples. That's how insurance companies sell, and that's how you have to sell the business case to management.
Fair enough. Cesar, briefly, if you would, anything that you would add to that?
No, absolutely. What Randy mentioned, in the very beginning, when we start with with the customer's requirement, analyzing these things, the only way that reflects directly is what happens if you have a PR problem. Okay, what happens if your device that you are putting into the market and the solution you put into the market is getting hacked? Okay, what is the PR that you will have with your customers? What is the implication that has these things? After going and understanding the risk that we are putting, for example, in a smart home, okay, we found that with the customer together and the different partners that we work, that we must have security for avoiding any problem or any risk regarding these things. Is your branding what you are putting in the game here?
Yeah.
In the end, I think it's even though I presented it as something you have to sell. In the end, today, you're making an IoT product where you're connecting to other people. They expect that. It is part of. It shouldn't even need a business case. It's part of the designing the product.
Briefly, gentlemen, if you would, we've got 30 seconds each on the last question. Someone says, you mentioned that a connection was changing the security for legacy devices. Can I improve security by only connecting devices when needed? I feel you've touched on that, but anything you'd add to that, Randy?
Yeah, it's a good question, because oftentimes we approach these things like, oh, well, we want to be connected all the time, and the customer's like, oh, that brings me lots of concerns. There are a lot of really compelling business cases where even being able to connect only when the machine or the device is having a problem, it's still worth doing, and it definitely makes the customer feel much more comfortable when they have control of turning things on or off. So it's a case of, if you can't be connected all the time so you can do all the great analytics and data monitoring and proactive response, even being able to have connections when needed could still save you travel time and the ability to update things faster, that kind of thing. So
Yeah. Cesar,
Just a different option.
If you could just add anything that you want on 30 seconds.
Absolutely. And this is, for example, when we talk about the smart home, it depends on the mode, for example. Several people, and we implemented that, want to use, full connection when they are not in home because they want to have a secure system. So you can start up and turn on and turn off when you want to be full connected. And it's a very valid use case.
Excellent. And thank you, gentlemen, for keeping yourselves so well to time. The aim, as we all know today, has been to try and discuss the importance of secure device management in the IoT, and already we've heard a lot about the difficulties, but also I think it's fair to say about the enormous opportunities, not least of all in the smart home. As long as we get the IoT device security right, and that means right from the start. Sadly, we're out of time now. Can I ask you to bookmark our website at iot-now.com, where you will find the latest news, interviews, blogs, and videos, and where you'll be able to stream this webinar tomorrow. It just remains for me to say a huge thank you to our speakers on your behalf. First of all, Randy Thompson of Wind River, thank you.
You're welcome. My pleasure.
And also to Cesar Martinez of Intel. Thank you, Cesar.
Thank you very much, Jeremy.
Most of all, ladies and gentlemen, I want to thank you for joining us. Keep safe, and we really do appreciate the time you spent with us. From everyone here at IoT Now, enjoy the rest of your day. Bye for now.
Bye-bye.